Good morning. The last morning without me, hopefully, as long as I can get out of the woods in an airplane. I should be back Tuesday. So, logarithms. Don't let the long names scare you. They're really not that nasty. The key thing to remember with these are they are inverses of exponentials. Okay. So when I say inverse, what do I mean? If I have something like y equals the log base b to the x, and I want to solve for x, I'm going to make them exponentials because exponential and the log are going to cancel each other out. So b to the power of y equals b to the log base bx. They're inverses, so they cancel. And we have our transition to an exponential. Okay, sometimes it's very handy to use that property to solve for variables. Let's talk about something like log base 2 of 8. Okay, that is 3 because 2 to the third power is 8. Okay, kind of see the relationship there maybe. Let's say log base 3 to the 1/9 equals -2, because 3 to the -2, which is 1 over 3 squared, is 1/9. Okay, keep that relationship in mind. No doubt. There are some rules, just like we have rules of exponents. There are rules that we can use to simplify logarithms. Okay. This is one is very key, and you might be tested on this on the AP exam. If I have a log, some base, and then two numbers multiplied, I can split and add. Okay. Very similar to the exponential rule where you add the exponents if you have similar bases that are multiplied. Okay. Let's say the same rule for division means you probably guessed it, subtract. Okay. If there's a fraction here that's 1 over x, you can make it negative. The reasoning here is you'd use this rule and make it log base b of 1, and any log base b with a 1 in it is 0. Okay, so any log with a 1 right here is 0. That's because b to the 0 is 1. Remember that rule with exponentials. Okay. Log base b, if these two numbers match, the answer there is 1. It's because b to the 1 is b, exponential comparison. And then one that often tripped us up last year, if there is an exponent in here, I can move it out front like so. All right. Remember the change of base. Sometimes you get very unfriendly non-calculator portion problems. So if I had some log 10, and let's call it 200. Yeah. We can change that to log base whatever we want, really. I mean, it doesn't make it any friendlier, but you change it to whatever base you want, and then put this number here and this number here, throw it in the calculator. You have the ability to do this one in your calculator. This is the log key in your calculator. Okay, so I would just punch in log 200, and this would spit out. Okay, so most of the time you're actually going to change these. If I have something like the log of 25, okay, log base 2 of 25, sorry. I'm going to change that to log 25 over log 2. Okay, because now it's base 10, I can put it in my calculator. Similarly, I can also change it to a natural log. Because this is log base E. This key is on your calculator as well. Okay, very important key for you to know that's there. So, what if I have something like this? And we want to solve it for t. Well, let's isolate the exponential. Divide by 1,000. Okay, now remember the exponential inverse is a log. So I'm going to natural log both sides because that's base E. And I get 0.35t equals natural log 5. So t is natural log 5 over 0.35. You can punch this in your calculator. On the calculator-friendly portion of an exam, you probably will have to. Maybe not. On a free response, I say stop, because that is a number answer, no further. You may go no further, okay? All right, let's talk graphs. I'm going to put y equals e to the x on here as well, because they are inverses. We know e to the x does this. Please remember that inverses are reflected over this line. So that means that natural log x looks like that. And if you tilt your paper, you can actually see that they mirror over the line y equals x. Okay. Most logarithms are they're gonna follow this form. The question is how fast do they go up? Log base 2, log base 3, 4, and then you can move them up and down and left and right, just like you can anything else. Okay. Be careful. Let's say the limit as x approaches 0 from the right, the natural log of x, see we're coming from the right hand side, is negative infinity. Okay, we cannot come from the left, right? There's nothing over here. The domain is 0 to infinity. Notice the open bracket or the open parentheses that doesn't include 0. Okay. The range here, in fact, negative infinity to infinity, because it goes all the way down and all the way up. Believe it or not, this does not ever stop going up. Okay. I think last year we talked about the earthquake scale, and that's why we use logarithms to make it a smaller number, okay? Because every level up is a factor of 10. So quick and dirty on logarithms. Let me write down your work so you can get rolling on it. I'll be back Tuesday, so questions on anything you've done while I've been gone, please bring those. Okay, 1.6b, 11 through 27 odd, 29, 33, 40 to 42. A lot of those are odds. Okay, do the work, check your answer in the back of the book. Toodles.